Okay, guys, for the question 1 of assignment 1, you are given the voltage for an exponential to the minus of 3t. Okay, so this is a value here, but we have unknown here, t, t is unknown in the time domain here. Okay, and you also given the I as a function of time, and then is a minus 2 dv dt. So this dvt, this vt is really referred to this vt. Okay, so that means you can find the it by putting this inside this equation and do the derivative. Okay, you will get the it. So what I mean is the it is equal to minus 2 dv. This whole thing is v, so dvt dt. Okay, after you do the integration, you'll get some answers of something like this. Something e minus something t ampere. Okay, so if you forgot how to do this derivative, you can use a website here to show some guide. Here I show an example. Let's say you do the derivative here, you just pick here, you click on this dvdt, you can change dvdt or dvdx. Okay, now I'm doing the dx dt. Okay, so you just key in something like this, you can replace the x with the t, and then this website can show the result here, this answer, or this derivative. Okay, this is for the part 1. For the part 2, part 2 is asking for the the total charge flowing through this device from t equal to 0 to t equal to 1. So for this kind of calculation, the mean we have to calculate the total charge from this time to this time, we need to use something like the integral, the integration. Okay, so we can use the formula from physics. Charge is equal to integral of I dt. Okay, so after you got this I, okay, you take this answer and then you put into this equation, and then you do the integration of the I, and then you will get the result in one integer result. Okay, the unit is coulomb. The unit for charge is coulomb here. So if you cannot solve for I1, that means you cannot solve for I2, because I2 you need I1, you need for the part 2, you need the IT, put in here, and then do the integration. Okay, you also can use this website. Here's the integration here. Let me see. Integration. I think this is integration. Yeah, this integration. The shape is very funny, but it's an integration. Okay, you can use this website to do some review also. Okay, for the part for the part number 3, you need to calculate the power absorbed by the device. And the equation for the power is the voltage multiplied by the current. So the voltage is given here. This is a voltage. Okay, the voltage in a time function, and then we have a current. Okay, but this current you cannot use this, right? This dvt here, you need to use a current from here. What I mean is, the voltage, you can use this as a voltage, this equation you put in here, Okay, you take this one, you put in here, and then the current is this one. You use this one again into here, and then you just multiply together, and so this exponential was still around here. So you get something exponential minus something t. The unit is watt. Okay, so this for the part 3. So basically, part 1 is a, a, a derivative. Part 2 is integration. Part 3, just multiply these two equations. All right. For the B, section B here, section B number 1, you were asked to explain the Ohm's law. So this one is in your notes. You can refer to your notes. So you have to take note that the mark is 5 marks. I mean, you need to have explained at least 5 sentences. Okay. Try to explain at least 5 sentences here. You can also put in some equation. Okay, put in some equation to help you explain the Ohm's law. Okay, I think one line is not enough to get the 5 marks. Okay, so you need to be more comprehensive. Okay, on the part 2 here, you are given a circuit. So this circuit with one voltage source and 3 passive components. Okay, then we have a V out measuring this 3K. We take this 3K voltage as a V out. So if you look at the first part 1, he asks you for the current I1, which is this I1 here. So as you know, this node and this node is a 6 volt, and then if you pay attention to this symbol here, is the positive is below. I mean this you can treat this one as a minus 6 volt. Usually we put a positive here, right? So this one, you can treat this one as a minus 6 volt. Okay, and usually when we do the notation, example for this 1K, usually we'll write something like positive here, and then we write R 1K, then minus, right? Okay, and then for this one, usually let's say this one is R2. Usually we write the positive here, right? So you can see if this node is negative here, that means we have minus 6 volt across these two nodes, because this voltage just directly applied to these two nodes. Okay, so when we know the voltage across a resistor, and then you know the resistor value, of course you can use the Ohm's law to calculate the current, right? So this one is quite straightforward. So for the part 2, is quite straightforward. I think you should use the Ohm's law, Ohm's equation, to calculate for I. Okay, for the part 3, since this two node is minus 6 volt. Okay, if you put the polarity exactly the same here, positive at below and then negative at the top. Okay, and because these two nodes is a minus 6 volt. Okay, you can go around the loop like this. Usually we put plus, let's say this is R1, right? And then let's say this is a plus, let's say this is R3, plus and minus, right? So if usually we start from here, so you can start something like minus, sorry, this is a plus 6 volt, okay, plus 6 volt, oh wait, sorry, I think we shouldn't say, it should be the minus here, it should be the minus, not the plus, because it's upside down right now. Yeah, I think should be the plus. So I think should be the plus. I think we just follow the this method. So we start from here plus 6 volt, and we need to minus this voltage and minus this voltage, and then we get the 0, right? This is a KVL. Based on the KVL, plus 6 volt, I refer to here, need to minus this voltage here, minus VR1 and minus VR2, okay, must be equal to 0. Okay, so if you think that this is a plus also, you also can do your own. If you assume this one is a plus, okay, if you assume this one is a plus V1, then plus this one must be equal to 0. So you see now you have a positive 6 volt. You cannot just add 2 more positive 6 volt to get a 0, right? It doesn't make sense, right? One positive 6 volt cannot add 2 more positive number to get a 0. So these two number must be negative, right? So I think at the end you will end up with plus 6 volt plus you need to have minus VR1 and then plus another minus VR2, because 6 volt minus this, then you get a 0. This makes sense, right? But because this is according to the Ohm's law, this is a true. Plus 6 minus R1 or plus 6 plus, depends on whichever method you want. You want to start with the negative or start with the positive. At the end, you must get the 0. So you need to figure out what is the real value here, so that this value plus this value will get the 0. But if you know the basic mathematics, right? Positive number plus 2 number will get a 0. So this 2 must be a negative number, right? This is the logic, right? We cannot add 3 positive number and get a 0, right? So this 2 must be a negative. But if you follow the analysis method, plus and then plus back to 0, right? Plus here, plus here, plus here, and back to equal to 0. You can write something like this. Nothing wrong, but at the end, I can assure you that the VR1, it must be a negative value, okay, and the VR2, because this is the power supply, this one is the one to consume the power. So this one cannot be, if this one is the negative, this one must be positive, right? They must be opposite. Because one is giving the power, this one is using the power, So the voltage must be different. So if this one is you think is a positive, then this two must be negative. Okay, to make sense. I hope you understand now, okay? Actually, the theory is quite simple. Probably I explain too much. Probably when I explain too much, probably sometimes you're a confused student. But I need to tell you that the theory is quite simple. There are so many ways you can explain this circuit, okay? There are probably 2 methods you can use. Either you go this way or go the other way, eventually you will get the answer, okay? And then the answer, actually the answer must be making sense. When you put in the answer here, it must be making sense, okay? All right, let's come to the questions part C. So on the part C here, question 1, okay, you are given this unknown kind of unknown load. You know that one of these 3 must be supplying the power, the other 2 must be consuming the power, or called the power dissipation. They dissipate the power. So one give, the other 2 receive. So right now we don't know which one is give, which one receive, but we can do the simple analysis. So for the part A here, you need to know which one is supplying or which one is dissipating. So let me give you some kind of example here. Let me give an example here. Okay, let's say you have one unknown power supply here. Okay, let's say this power supply is 10 volt. Okay, then it go through one unknown and then one unknown, and then you connect back to 10 volt again, right? Okay, so if this one you know is 10 volt, the other one you know is let's say 6 volt, and the other one is let's say 4 volt. Okay, so plus minus here, and then plus minus, right? Plus minus. So to make sense, according to the KVL, the sum of all the voltages in the loop must be equal to 0. So if you start from here, minus 10, right? We start from here, then we go around, then we see the positive here, positive 6 volt, plus another positive here, positive 4 volt, must be equal to 0, right? According to Ohm's law. And then from here we can tell these two, you measure 4 volt and 6 volt. This one is a minus 10, right? Altogether they become 0, right? So when this one receives a 6 volt, when these two add up, is equal to this. So it's really clear that this one is the one to supplying the power. Based on the logic that this 2 is a positive, this is minus. So this one is equal to this 2. When this 2 is positive, that doesn't mean it's supply power usually. Okay, when the two positive, usually the power supplied by the one having the largest value here, even though it's negative. So this value, this negative 10 volt transfer to this 2. Okay, so we can say that this one is supplying, this one is the dissipating, and this one also dissipating power. So this is for the part 1. And for the part 2, it's quite simple. To calculate the power supply or absorbed by the 4 volt source here, wait. We are jumping to the question 2. Determine the power dissipation for each element. So we have 3 elements here, and then we know that there's only one current flowing through. Because here there's only one loop, only one current loop, which is a 25 ampere. And then you know that the power is equal to, let's say this is A, so the power of A is equal to V times I only, right? Very simple. Take the voltage multiplied by the current. So the power for the A would be 10 times 25. 25 times 10, so it's a 250 watt. Okay, so let's say this is 10 minus 10, right? Minus 10. So let's put a minus 10 volt here. So we get a minus 25, 250 watt. Okay, so minus means is supplying power. Example in your home, let's say this is your heater. You got a heater at home. So if your heater is drawing 1000 watt, or your aircon is drawing 1000 watt, usually we refer this one as a positive, right? Positive means you consume 1000 watt. So the one to supply the 1000 watt is a TMB, right? TMB supply the so TMB here must be minus 1000 watt, right? So usually minus means supplying power, positive means consuming power. Okay, so from here, if the value is minus, that means is the one that's supplying the power. Okay, usually the one consume power will put a positive. Positive means consuming or absorbing the power. Okay, I hope you are clear about question number 1. Oh, see. Okay, that's it, guys. I'll continue with question 2.